All right, well, I'm going to get started now. As you can see, I know how to use Windows. Despite the popular belief that Dr. Guy does not know anything about Windows, I can get around a little bit and I can get certain programs started. All right, so the reason why I'm starting with Windows today is because I want to show you how you can do your homework. There are many ways to do it, but whatever you do, you have to use the 32-bit Linux assembler in order to assemble your program, because that's what I'll be using in order to grade your programs. So that means if you want to use Windows, you will have to run a virtual machine that is a Linux box, and then use that Linux box as a virtual machine to do your homework. For people who do not like to use command line interface commands, I'm sorry, but this is the way it's going to be for this semester. Okay? It's not going to be that bad, at least, I don't think it's going to be that bad. Because everything is getting recorded, including, this session here is all getting recorded. So let me go into Moodle first, and then I'll show you guys, what you need to download and what you need to do in order to run the virtual machine. So first of all, log into Moodle. And by the way, I have good news for everyone. I'm going to add everyone who wants to add to this class with the prerequisites. Okay? So people without the prerequisite, will still have, I cannot add those people. I'll have to drop people without the prerequisite of CISP 360. Okay? But otherwise, if you have the prerequisite, or if you have successfully challenged the prerequisite, I will still add you to this class. So that means this is going to be a big, huge class. I have some extra add number printed just to be sure. So I have 35 permission numbers right now, ready to be passed. I'm not going to give it to you, one by one, have people lined up, because that's just going to be taking too much time. So I'll pass that around so that if you are waiting to add to the class, whether you're on waitlist or not doesn't matter. Just write down your name next to the next available number. Write down that number, and then use it as soon as possible. All right? Are there any questions about that portion? No questions? All right. All right. So let me log in first, and okay, as usual. Not type my own password. Let's see, just for now. Okay, so this is something that you can do as well, even if you're not enrolled in class at this point. I think I showed you guys how to self-enroll into Moodle last time. Okay, and I think some people did, but not everybody did. Okay, because I could only see a few people manually added to the Moodle site. So if you have not done it already, please do so. All right, so this is where we need to talk about. The first part would be here under topic 1. You can see that there are 2 image files. One is for VMware, and then the other one is for QEMU. So depending on which emulator you want to use, you can select to download one or the other. They are basically the same virtual machine image. Okay, it's just that the format is different. One is intended for Vmware Player or other VMware products, and the other one is for QEMU, which is an open source emulator that you can also use for this class. So, take your pick. Most people just pick VMware just because, we have that already installed in the lab and, on most of the computers in 152 and other classrooms here. Okay, so I'll just be making that assumption that you'll be using this one. So I'll go ahead and download this particular file. And, okay, this is a different browser. I'm going to click it first. And click download, save link as here. It's a relatively large file, but because it is downloading, within the district, it's still pretty fast. It's half a gig, and it's going to take me about a minute to download here. So it will be a good idea to download it in the lab so that you don't use up your precious bandwidth at home. Then you can watch more movies, like my YouTube, stuff. All right. So as this is being downloaded, I'm going to get VMware Player started. So we go to All Programs, go to VMware, and start VMware Player. VMware Player is available for all major platforms, so you can download and install it from vmware.com for Windows, for Mac OS X, and also for Linux. So it's across all the platforms. Okay, this is what VMware Player looks like. And my download only has 5 more seconds to go, and then it's time to decompress it. Yep.
Would it be possible to tell it into the schools? Like,
I have not set up any accounts on the Power server for this class, mostly because when we are debugging our assembly programs, occasionally we run into infinite loops and stuff like that. So I don't want that to impact the rest of the server, and so instead we'll be using virtual machines for this particular class. Okay. All right. So once we have the zip file downloaded, okay, you guys ready over there? Okay. So once I have the file downloaded, I can decompress it. I'm going to decompress it to a local hard drive here instead of my external hard drive. But if you want to be able to do your homework here and also at home and on most computers with VMware installed, you want to decompress this onto an external hard drive. I do not recommend USB thumb drives because they typically are slower, much slower. But if you have a fast one and you think, well, it can handle it, go ahead and give it a try. This file decompresses to, I think, around 1.5 gigabytes. So in terms of size, it's not really that bad. But still, there will be a lot of write operations back to the file. And as a result, you might want to consider an external hard drive instead of an extra USB thumb drive. All right, so I'll go ahead and extract the files to the C:\/ location here. So just maybe a little bit refined. Okay, I'm gonna specify a little bit different here. And go to my documents. There we go. The decompression looks quite fast here. Okay, that's because I'm decompressing to an internal hard drive using SATA. So that's pretty fast. If you use an external drive, you have to go through USB 2.0. It's going to be very slow. USB 3 is going to be fast. If you have a thumb drive, it's going to be quite slow as well. So do not expect to get this kind of performance when you're doing it with a USB device. Any questions up to this point? No questions? Yep.
So what is the point of installing into an external hard drive instead of just a hard drive on your computer?
So that you can take that drive to any computer in our computer lab and be able to continue with your homework assignment. Yep. If you only plan to do your homework assignment on a particular computer, you can just decompress it onto that computer. You can move the files later onto, as long as you move the folder as a whole, it's going to be okay too. Okay. All right. So now it is decompressed. It is within this folder. So I'm just double-clicking the folder to show what files are included here. So we have all the virtual machine files included here. The largest one being the disk image is 1.7 gigabytes at this point. But it can even grow further because it is a flexible file. So as you require more space, this file, which is representing the entire drive from the perspective of the virtual machine, will get bigger as well. All right, so getting back to VMware Player, I'm not going to use any one of these. So what I would do is I'm clicking Open a Virtual Machine, and then I'll tell VMware Player where to find that file. So it'll be under my Documents, under Debian 6, and this is the file that I'm going to open. It's debian6.vmx. So click Open, and now we have the virtual machine already open. Now it's open, but it has not started yet. So you have to click the Start button or the Play Virtual Machine button to get it started. It is allocated 512 megabytes, and I think you might be able to get away with 256 megabytes. If your desktop or laptop computer does not have a lot of RAM to begin with, and you don't want to give too much RAM to the virtual machine, you can probably bump it down to 256 megabytes and it'll still work. Okay. And right now, I'm not going to edit any machine settings. Later on, I'll tell you guys why we have to modify certain parts of that. So we'll just click Play Virtual Machine, and it'll give you a bunch of warnings and whatnot. We'll just go ahead and say, I copied it. Go, and it's just complaining about certain things. Go away. All right, there we go. So now we have Linux starting up inside a virtual machine, and obviously, if you have a more powerful processor with virtualization acceleration, the VMX flag extension, it will run significantly faster. So it's already up and running. See, the server doesn't take long to bring up, much faster than Windows itself, which is not running as a virtual machine. All right, so once you get here, there are two accounts that you need to remember. The first one is the default user account. The username and the password are both user, U-S-E-R, all lowercase. The administrator account is root, R-O-O-T. The password of the administrator account is ball, B-A-L-L, so root ball. Okay. Yep.
That's all lowercase?
All lowercase. Yep. Everything is just lowercase. All right. So just to test it, I can say, well, let me log in as user. Now, if you type when the window is active, it doesn't do anything. You have to click in the window first so that it grabs both the mouse activities as well as keyboard activities. So at this point, my mouse is lost because it is completely captured by the virtual machine. If you want to release the, to return to the computer, most of you probably just saw that little message, press Control-Alt at the same time, and then I get my cursor back, the mouse cursor back. Okay, so remember, click here to get in, so you can type user, and then type the password, which is also user by default. In Linux, when you type a password, it does not echo anything. So it doesn't even give you the asterisk because it doesn't want people to know how long a password is. Because I can pretend this is a really long password just by hitting the shift buttons. So most people would think, wow, it's a long password. No, it's just user. All right, so I just logged in as the regular user, and that's good. Okay, it's good verification that it is working. Are there any questions up to this point? Yep.
Yeah, I was doing that. I installed a VMware that we told us to do last time. It just did not work for me. It wants me to, whenever I try to go into it, it told me to go to a list of programs to search something. Do they have to download a VM Player separate, or is it like everything is in Debian 6, right? This one we have to download it anyway, or this is something I need to download there.
You can probably just use whatever they have as a Debian. It's not working.
Nothing at all.
Well, I don't know. If I cannot see it, I cannot really help you fix it. Okay. All right. Okay. So this is all good. So I'm gonna log out of the user account first. Okay. Just type log out, and this time I'm gonna log in as administrator, which is root, and the password is ball, B-A-L-L, and I'm now logged in as root. There are several things you really should do before you do anything else. This is a really base installation of Debian Linux. It does not include the tools that you will need to take this class. So the first thing you want to do is to first bring it up to date, and then two, install the tools that you will need for this class. To bring any Debian distribution up to date is really easy. The command, or one of the commands to do it, is called aptitude. Okay? So you just say aptitude update, semicolon, so that you can separate one command from the next, and they will be on the same line. And then the second command is aptitude save upgrade. Okay. So these two commands will bring the distribution up to date. It might take a long time because this is something that I did last year. Okay, so there has been almost a whole year that I have not updated this particular virtual machine. So it's going to take a little bit of time. There will be some files it has to download. So once it's started, I'm going to go back to the notes and continue the topics a little bit, and then we'll come back and check on this later. It's kind of like an infomercial for Toaster Opens, right? We'll get it started, and then we'll do something else. Yep.
It was a semicolon to separate it?
Yeah, semicolon to separate the two commands. This is all getting recorded, so you can replay the whole thing, at your
Or
convenience.
you can do one by one, right? So one by one, but you can do the after you update and then you can do the upgrade later on. One by one.
Yes, but if you want to install the additional packages, you have to do the update and the upgrade, then you can include the. Yep, it's asking me whether to continue. So click yes, and it's going to download a whole bunch of files. All right. So are there any questions about this process at this point? Yep.
If we can use another flavor of Linux, is that okay?
Absolutely. You can use any flavor you want as long as it is a 32-bit version, because you'll be writing 32-bit instructions for this class. Okay.
Just update the packages that we need for the class.
Right. I will list the packages that you need for this class.
Yeah.
Right.
You need to list them.
Yeah, it's already on the website.
Yeah.
If you read ahead of me, you know that the names of the packages are listed already. But that's only from the Debian and Ubuntu perspective. If you have Red Hat or Fedora, they may not be named the same way. Question?
I have 62-bit and 64-bit, and I can
64-bit?
I can compile.
Oh, okay, so you can handle 32-bit too?
Yeah.
Okay. So are there any questions back there? Because I keep hearing, keep chattering. Do you guys have any questions back there? Nope. Okay. Anything to add to it? Nope. All right. All right, so this is going to take a while. I'm going to switch back to my notes so I can get started with the topic instead of just waiting for this process to finish. Okay. There are other alternatives too. If you already are running Linux on one of your computers, you can definitely just use whatever distribution that you have already. It's just that when you do your homework assignment, I need your account to be based on your last name, because that's how my grading script is going to pick up your file, and so I can use a script to grade your homework and know who did it. Okay. So by the time we have the first homework assignment, it will be clear how I want you to set up your homework assignments. All right. And here's a little program. It's called bad return. Okay. It doesn't look very harmful. It's a little harmless program. I'm just gonna make the program larger here. What do you think this program is going to do? Well, let's go ahead and give it a try, won't we? Okay. On the other hand, I'm not in my usual Linux distribution, so I don't really have the tools to do it. So I'm going to cheat and use the power server instead. If this ends up in an infinite loop or something, we might hear some screaming from next door because they're teaching a web class from next door, and they're going to use the power server too. So if the power server goes down for any reason, there might be some screaming. We'll just kind of ignore that.
Just close it like it went down for you too.
Sorry?
Just close it like it went down for you too.
Yep. Restart the server.
There you go. And you can do that.
All right, so so I'm cheating here because I'm going to the power server, and later on I'll show you how to open PuTTY to your virtual machine. Okay, because you probably will want to do that. So I'm going to go into my power server account. Here's my password. I'm going to slide this one over a little bit so I can see the program that I'm copying here. So I just call this a bad return.c. And instead of using any tricks to get the program in really, really quickly, I'm just going to type it. I will teach you guys, tricks to get a program in, really quickly. How many people know what is printf?
Displays the console or the terminal.
Because I think in your C++ class, they teach you to use the greater than and the less than C out and C in. Yep. This is actually plain C. It's not C++. Sorry?
In 300 they teach you scanf and printf.
Okay. Do they teach you all the variations of printf? What kind of format it can take?
No. I don't remember that.
They just point you to the man page, right?
Yeah,
And say, okay, here's the man page, read it. All right, okay. So I just finished writing. Did I miss a semicolon? Okay. No, I did not.
It's on the X8.
Oh, okay. On this line. Thank you. All right, so I'm going to do a gcc-o bad return.c. So it will compile and give me the executable in one single command. And here is the program itself, bad return. And it gives me a segmentation fault. Not quite what I expected, but I can tweak it so that it will give me some really weird results.
That's what I got too.
It depends on how the code is generated, so this one we can change it a little bit. I can doctor it, to the point where it will give me the result that I want.
Maybe a second terminal window would be up right now.
Okay. Maybe I'll do something like this instead. Okay, this is something that that you can do in C, but it's probably not a very good idea. Okay, here's something that I can do. Let's see. Okay. So I want x plus 4 as my base address. I'm going to cast it to an integer pointer, and then I will I'm going to turn off syntax highlighting because it makes it harder to read. I think most of you still cannot read it, can you? Yeah. Okay, let me turn on make the font a little bit bigger. Under show settings. Yeah?
You have it trying to go outside the array.
Yeah, it is already outside the array.
Yeah, that's why you're getting segmented.
Yeah, I know, but I want to get outside of the array, but I want the symptom not to be just segmentation fault. I want it to be something weird, right? Okay, so let me get to appearance, change the font. That should be big enough.
Background white. Background white.
Black and white?
The background.
Black and white has other problems, so I'm not going to do that. Okay, but at least the font is big enough now. Can you guys see it from all the way over there? Okay. Okay, so this is, just an instruction. It doesn't seem very harmful. I'm just adding 4 to a certain location, and seemingly it is a location that belongs to a local array. Okay. All right. So let's go ahead and see what this is going to do. I think plus 4. Let's make it plus 8. I'm just, testing it here. Do the GCC and run the program again. This is not too weird, so it did not do anything weird. Well, how about this? And of course, it's not going to let me do that unless I change the type here. So I'm going to change this to I have to change this one here. Oh, change the other one? Yeah, we can do that too. Change that to integer pointer. Or change it to an integer, that's it. Okay, change that to an integer, and we'll see. Error, undeclared.
Zero declared F, yeah.
There we go. All right. It still doesn't do it. I'm trying to get it to return to the wrong place. That means this is not the return address. I think it's x plus 8. So let's do that again. Huh, still doesn't do it. Okay, I'm going to fast forward to some of the class material here because I need a little refresher. So here's the return address, and it doesn't take any parameters. It has a local. This is EBX, and here is my local variable. So we got 1, 2, 3, 4, 5, 6, 7, 8, and this is the location that specifies the return address. So it should return to F and printed what is weird, the way it's set up right now. Because this is x plus 0, 1, 2, 3, 4, 5, 6, 7, and this is x plus 8, and I'm changing that location to the address of function f. So we really should do the trick.
You need to use char instead of int, because int itself.
Yep. Yep. Okay. You're right. Well, it's already a char. That's what I need. Extra pair of parentheses. Okay. We got it. Okay. The segmentation flow part is okay. Okay, because we know we need something really bad to memory. But what is weird is it is printing this is weird. Okay? How did it happen? Let us just look at the code again, okay? I did something in subroutine G. Okay, let's look at the flow of the program first. Main is right here. Main calls G. G is not calling anything, okay? G doesn't call anything. It has a local variable, which is an array. I do something about pointer arithmetics and an assignment statement and the dereference. But when G returns, somehow it returned to F. But I never called F. How can I return to F when I never called F? And there's nothing that is non-C in this program. Everything is straight, C. The compiler, says everything is okay. Type checking worked out just fine.
When function is finished, trying to return to stack, upper stack, you will write to returning address.
Yep.
By
Exactly.
address of F.
This is why I had to draw a little diagram to remind myself, which location I have to hack in order for it to return to a particular place. In this case, I don't want it to return back to main and continue execution with a printf. I wanted to continue execution in the subroutine F. And I was successful in doing that. Okay? Are we doing okay so far? Okay? Now, somebody can say, but Tag, you intentionally hacked this program to make it behave like this. Well, yes, I did. Okay? However, it is possible that you have something else instead of this particular statement. Let me turn on the line numbers here. Instead of the line 7 that I have in this program, which is definitely, just forcing the program to do something weird, instead of that, you can be overwriting something that does not belong in the array, and just magically, the byte or the word or the long word that you change, just by coincidence match the address of another subroutine. And then by the time you return from G, you'll be continuing execution at a place where it doesn't make sense at all. Is it okay so far? That is the reason why I think I want to teach this class, is to show you guys something like this, and we will have the ability to look at the symptom that we saw a little bit earlier and say, well, just knowing high-level programming languages does not explain that anymore. But knowing what the program translates to and how it utilizes memory on the stack, then it suddenly starts to make sense. It's like, oh, okay, I know something on the stack is messed up. And how can something on the stack get messed up? Usually it is because you're using a pointer to point to a location where you think you have space in the array, but it's actually beyond the array that you try to access. Okay, and therefore you're modifying something on the stack that has importance when it comes to the flow of the program. Okay, that is what I think would be the purpose of this class. Not so that you guys can become programmers and write entire programs in assembly language, but so that you can debug your C and C++ programs more effectively. Is that okay so far? Okay. All right. So with this out of the way, I'm going to continue, and we can shrink it a little bit, with the virtual machine, because this part is done already. It's still installing some additional stuff, so I'm gonna get this process to continue, and it's gonna take another few minutes or so. So now let's go back to my notes here, and continue with why assembly language programming. So, any questions? Has everybody kind of read this part? Have you guys read, this document a little bit? Okay, good. All right. So, as far as this class is concerned, I think we really kind of need to understand a little bit about what is a compiler, its job, what is a linker, its job, and also what is a loader, which is something that we don't usually see. A compiler is easy. The compiler is a translator that translates the source code of a high-level programming language to object code. Object code is basically machine code already. Okay, so it seems like that really is the only thing that we need. Okay, we can go from a C++ program to the machine code representing the same logic, but in a way that the processor can understand. So why do we need anything else? Why do we need a linker? Let me ask you this question then. How many people have used multiple source files in your C++ class? Okay, a good portion. That is why. Okay, and why do we want to use multiple source files when we are writing programs?
To make it manageable to find bugs and stuff, or add new features.
Okay, so go ahead.
It's just better organization. It's a lot easier to accept and take bugs and that stuff.
Work in teams.
Work in teams, okay, work in teams is one. And also, certain files you may be able to recycle in your next project. Okay, if you look beyond the horizon of homework assignments, okay, there are certain things that you probably need for different types of projects. So you want that stuff to be separated from the rest of your project so that you can share that code with all of your other projects. Is that making any sense? Okay.
Like the Gecko rendering engine was originally in Firefox and then moved also to Thunderbird.
Right, but that one is actually, I would assume, it is already in tens, if not more files in terms of the number of source files involved. Okay, so that's a good reason. And that's why we need a linker. Okay, because from one source file, you may be referring to another subroutine defined in another source file. So when you have object files created from each source file, they have what we call unresolved references. In other words, this source file will create an object file But inside the object file, it's going to say, oh, I need to call this particular subroutine, but I don't know who is defining it, nor the location of that subroutine. The object file has unresolved references. So when you have all these object files created already, you need a linker to basically go through all the object files and say, okay, you are looking for label A, and this guy is defining label A, so let me use that to resolve that particular unresolved reference. So it will go through all of this stuff here until all the unresolved references are all resolved. The other thing that the linker does is it will quote-unquote concatenate all the object files. In other words, instead of having a location 0 in all of the object files, they now will be concatenated into one big piece of code. Okay? And in that process, the addresses will also change, and the linker will basically resolve all those changes as well. So the linker is going to produce what we call an executable, which is quote-unquote the program that you can run. The program that you can run is going to require something to load it into the memory of your computer, and that part is the job of the loader. Okay, so the loader is something that you don't see, there's no command line to do it, but it is a part of an operating system, so it can start the execution of a program. Okay. All right, so that's just a really quick view of what is happening when you compile and link a program. More on compilers. Compilers have come a long way. Well, how long have we had the C programming language? Not C++, but just plain C.
1970s.
About 70. Okay. How do you guys guess? 1970.
I've read about it.
Oh, you read about it? Okay. Sorry. Wikipedia. That definitely helps.
78 when C++ came
But
out.
sorry.
78 when C++ came out, right?
C++ 78, I think it's later than 78. The adoption doesn't even start until the 80s. So C++ may have been floating around for a long time, but there was nobody using it until at least the 80s. Okay. Well, the reason why I can remember 1970 is because the way the computer represents time is it's counting the number of seconds since, guess what?
1970.
Exactly. So that has significance. What about DOS and Windows? DOS and Windows internally represents time as the number of seconds since 1980. So that tells you, when MS-DOS and Windows came around. All right. Now compilers have come a long way, which means before. When you look at the evolution of the C programming language, it has gone through a lot of revisions already. The original C compiler does not do type checking. Yep, you can assign anything to a pointer. It doesn't check. Okay? Well, that's because of one obvious reason. What was the intent of the C programming language originally? It's basically a macro language, but who was the intended target audience? Who was supposed to use the C programming language?
How people are programmers?
Programmers, okay? What type of programmers are we talking about here? Professional grade programmers. The two guys who wrote Unix. Okay? The C programming language and Unix are closely related. You can even say the C programming language was a byproduct of Unix. The two guys who was writing Unix was getting tired of writing everything in assembly. So they invented a macro language so that they don't have to specify all the details over and over and over again. Okay? In other words, C as a programming language was a pragmatic language invented by experienced high-end programmers for themselves. It was never intended as a learning language. So type checking, we don't need type checking. I know what I'm doing. That was the mentality. Okay. Now, in terms of advances, in computer science, in terms of programming languages and optimization, code generation and optimization for single processor system is pretty much a done deal. It's a dead horse. Okay, there's nothing else to do to optimize the output from a compiler. If you turn on the optimization of GCC and you look at the output, it will beat most programmers. Okay? In other words, you give the pseudocode to a programmer and say, I want you to implement this logic in assembly language. And then you turn around and write a C program, and then use the C compiler to compile that code with -03 or -02, as an option. The compiler, most of the time, will actually generate code that is more efficient than a professional programmer can, because it can consider many different types of combination of instructions to implement exactly the same thing and pick the one that is the quickest. Okay. And that's why you might think, well, why do we even need to learn assembly language programming? Because compilers are now better than actual people writing assembly language code. So that's why, this is why, okay, there are still certain things that we cannot program in high-level programming languages, even today. Well, the first one, and I would like to point this out because it really is a good reason, is we sometimes have to program microcontroller units that are so inexpensive that they don't have enough resources for C programs to run. What are we talking about? Limited resources. I'll give you an example. I will search for that particular part, and it will explain everything. So I will go to a place called DigiKey, where you can purchase electronic parts. And the one that I'm looking for is ATtiny, which is an entire family of microcontroller units. And there are 1,029 of these things. So I'll be looking for one specifically that has few, not a whole lot of resources. So we'll look for, program memory is 256 locations by 16 bits. That's all that you have to specify your program. Did you guys hear what I just said? You have 256 locations to specify your program. Each location is a 16-bit location. In other words, you have 512 bytes for program code. Okay? So we'll take this one, as a criterion and search for parts. So apply filters. And we have 19 products, matching that particular criteria. And we'll go ahead. And if you look at these packages, does anyone know, electronic packaging in this class, especially the surface mount type? Okay, how big is an SOT23-6 part? How many can you fit on the fingernail of your pinky?
7, probably.
4 or 5.
Yeah.
Okay, so you can fit 4 or 5 of these chips on the nail of your pinky. Okay. So let's pick that part and figure out, why would we even use a processor that limited, and that small? Okay. So here we have, the actual image of the part, and if we order 4,500 at a time, the price is 38 cents and 38.75 cents. It's less than 40 cents for each processor. Okay. That is the reason, because the processor is so inexpensive, now you can put it into products that are also very inexpensive, like Furbies. Okay? I'm not kidding. I mean, if you look at a lot of consumer products, they probably have something like this in it to do the processing. Because this processor, even though seems like, well, it's 40 cents. With 40 cents, I can buy resistors, capacitors, and whatnot. All the analog circuit stuff to implement maybe something that remotely resemble the behavior that you want. But this is far more flexible, and most of the time, the digital approach is actually less expensive than the analog approach. Okay, and that's why people use these parts. It's self-contained. You have a little chip, tiny little chip, you give it ground and 5 volt, or whatever voltage that is specified to run at, and it will run the program. You have 256 instructions. Each one is 16-bit wide, and that's your program. Let's click on this item so we can see more details. Okay, so for this part, we can look at the data sheet. The data sheet of these parts, basically is a full specification that will tell you everything that you need to know to put this on the circuit board so it can work with everything else, but it will also tell you everything that you need to program it as well. So we'll make it a little bit bigger so we can all read it. All right, this is an advanced Risc architecture. It has 54 instructions that you need to learn. That's not a whole lot. I mean, you just have to remember how to use 54 instructions. And that's why it's a Risc. What does Risc represent here? RISC, Reduced Instruction Set Computer. Okay, as opposed to CISC, CISC, for Complex Instruction Set Computer. Okay. How many instructions do you think are available for a typical i3, i5 processor? It's in the hundreds. It's in the hundreds at least. You have 16 registers. Each one is 8-bit wide. You can run it at up to 12 million instructions per second. And you will say, well, that's not a whole lot. I mean, that's pretty slow. It's much faster than the IBM AT computer already. Do you guys still remember the IBM AT computer? No, because it was before your time. It was before your time. And that really shows you how fast technology has advanced over the past 15 years, 20 years or so. For this particular part, you have 512 bytes of in-system programmable flash memory, which means you don't have to take the chip out of the circuit board to reprogram it. Okay, it can be programmed in circuit when it's soldered on the circuit itself. And that's all you have for RAM. 32, not kilobytes, but just bytes. 32 bytes is all that you have got. Reminding me again, how many registers do we have? We have 16 registers. So it's mostly just the registers, because registers actually count for RAM in this case. Do you think we have space for the stack or the heap or anything like that your C program needs? No. Absolutely not. So how are you going to program these things?
Assembly.
Assembly. That's your only option.
Or binary.
Sorry?
Or binary.
Or binary, yep. Mm-hmm. But the assembler is actually pretty good. Interestingly, even for a part like this, which is an 8-bit processor, there's a GCC port for it. The entire GCC GDB chain, tool chain, is actually ported for this particular processor. Almost from its inception, it already has support from the GNU tool chain, which is very nice because it makes programming these days really easy. You just have to get the cross compiler, and everything works just the same way as your regular compiler or assembler or linker. So are there any questions about this? Any questions about why sometimes we have to program in assembly language? No questions? Okay. Yep, go ahead.
How different is programming a chip like this versus the assembly for an x86?
In a way, not much. And in other ways, yeah, there are some differences. The difference between a CISC architecture and a Risc architecture is there are addressing modes, particularly for a CISC architecture, that cannot be done with a single Risc instruction. In other words, sometimes when you have a single CISC instruction, you have to break it down to 5 or 6 or even more instructions for a Risc processor. Okay? But in terms of the concept, it's about the same. They both have indirect access, jump instructions. Most of the modern concepts, are already here in a Risc processor like that. Yep.
When you say it has to be broken down, is that because it needs to be like an operation needs to be done over multiple cycles of the processor?
It's because the operation that needs to be done is complex enough that a single instruction, there are no single instruction to do that type of processing with a Risc processor. Okay. Well, But here comes the next question. Even though no one is asking that question, I'll ask that question. Okay. So if CISC processors are so powerful, your i3, i5 processors are fairly powerful processors. They're not too expensive, right? So why do we want to have Risc processors? Because it seems like it's a step backwards, right? Okay, each instruction is simpler. It cannot do as much as a CISC processor instruction. So why do we want to use Risc processors when CISC seems to be a better way to go?
Cost.
Okay. Cost. Okay. So why is cost a factor in this case? When you have a CISC processor, you need additional silicon transistors in order to perform the operations, right? Does that make sense? Okay. So let's say this is the size, not to scale, this is the size of a typical CISC processor. When you have a Risc processor, the idea is to minimize the number of transistors. So you're trying to minimize the cost as far as the hardware is concerned. So now you have a CISC processor on the side, which is a lot smaller. Okay. So when you think about the fabrication process uses wafers, and each one is basically a disk. It's a little bit bigger than this. I think it's 300 millimeter wide. So this one, this is already bigger than the actual size of one. Okay, but in this case, so let's say we're trying to fit these processors onto this disk here. Okay, so we have I'll just draw a view just to get the idea across. Okay. All right. So you get the idea. We can only fit so many processors because of the size of the processor. Now, in any type of manufacturing environment, you are going to have flaws, on the substrate. Okay, you're going to have flaws on the wafer itself. The manufacturing process will introduce problems. Okay, so let's say we just randomly throw these defects onto the wafer. Okay, so the density of the defects will be the same across all the manufacturing, all the chips that you manufacture. Okay, so this is what it looks like for a larger processor or processor that has a larger die. When you look at the same size of wafer, but this time I'm manufacturing a Risc processor, so they're much smaller, and I can pack a lot more on the same wafer. But the density of defects would still be the same. I'm just approximating here. I think that's pretty close, right? So if you look at the yield, which is the number of chips that you can actually use, which one is a winner?
Risc.
Risc is a clear winner because the chances of having one of the defects landing on a die is pretty small. Relatively speaking, if you look at the total number of processors that you can make out of one wafer, and then you look at the number that has a defect, it's a small percentage compared to, in this case, because the die is much larger, so the chances of having one defect on a single processor is higher, is much higher. Okay, and you can push this to the extreme, right? If you look at a processor that would take the entire substrate, take the entire wafer, there's no winning, right? Because there will always be defects on that chip. So if you push that argument all the way over to a huge processor die, then it suddenly becomes very clear: the smaller the die, the better, the higher the yield. Does that make sense? Okay. The second reason why Risc is also useful, even in today's standard, has to do with this. Okay. Processing center. Not processing center. Data processing center. There we go. So when you look at a data processing center, I'm looking for images here. All right, so these are all really good images. This one I like the most. This is the first time I see this picture too. All right, so here we have a data processing center. It's sitting in the middle of some water. You can call that a moat, around it. Because we like data security, right? What is better than having a moat around your data processing center? And a drawbridge, right? You can have a drawbridge too.
Don't feel the alligators.
Sorry?
Some sharks and alligators.
Sharks, alligators, mutated piranhas and whatnot. 3-eyed piranhas. So, okay, you look at the data processing center like this. What do you think is limiting how much processing power you can pack in this particular building? Nice looking, great building. What is the limiting factor?
Heat generation.
At this point, it is heat generation. There's no way to extract heat fast enough, from these, data processing centers. And you think about it. That's why they have water in around it. And once you start up the processing center, it will go. It will just be evaporated, right? You need water from rivers, to come in and
No, if you make a
to cool it down.
cold enough water and then when you spend water, it will heat it up.
Well, cooling is the problem, okay? Nonetheless. Well, it doesn't seem to make any sense. Does it make sense to you guys that heat extraction is a problem, when you try to pack a lot of processing power in a small space?
Yeah.
If it doesn't make sense to you, next time you have a LAN party, do it like this. Have about 10 people, or maybe not even 10, 8, okay? Have about 8 people bring their super high-end gaming computers into one single room. Let's make it about 12 by 12, okay? 144 square feet. Now, normally, you can easily pack benches and whatnot and have 8 people working in a room of that size if you're working on calculus or some other homework. But if they all bring their super high-end gaming computers, you have 2 problems. The first problem is if you try to start up all those computers, the circuit breaker is going to break. Let's do some basic calculations here, why that is the case. What is the power consumption of one high-end gaming computer? High-end. Okay, so let's call it 850 watts when it's running, right? When you're actually running games. So let's even take a discount here. Let's call that 500 watts, okay, which is already giving a lot of leeway. Okay, 500 watts per high-end gaming computer. And how many did I say in that room? 8 of them, right?
4,000.
That's 4 kilowatts right there. Okay, 4 kilowatts. Well, okay, that comes later. Okay, because you might think 4 kilowatts of processing power, right? Well, what comes in must go out. Energy does not disappear. It only changes form from one to another. It comes into this room in the form of electricity, and it converts to what? Processing power, right? But processing power is not a form of energy. What type of energy are we talking about? Sound energy. We got those subwoofers, going in that room too. Well, no, it's mostly in the form of heat, right? You go to Target right now. What is the baddest heater you can purchase from Target?
Baddest or worst?
In terms of wattage.
Best one.
Baddest means the most,
The best one is the
the best. The baddest. Baddest. No, the circuit can only support up to maybe 1,800 watts. Okay? Close to 2K. Okay? What happens when you try to run 2 hair dryers out of the same socket from the wall? You break the circuit. Because what is the usual amperage per circuit breaker of a residential building? 30 amps. Okay? 30 amps. Well, you have 15 amp circuits too, but the most you can get is about 30 amps. 30 amps times 110 volts gives you the power. 3,300 watts. Okay, so out of one circuit breaker, you can only supply 3,300 watts. So let's say, okay, that's not a problem. We'll just have a few generators outside of the room to bring power into this room. Okay, because we really want that game going. Okay, now you have a secondary problem because now it is equivalent of running two or about three heaters in that room, full-time, 24, full-time with no duty cycle. When you talk about a regular heater, most of those have a thermostat on it, right? So when it gets to the set temperature, it just kind of cuts off until it drops below again, it turns on, it's a duty cycle kind of thing. When you're playing video games, there's no duty cycle. Okay? It's continuous. So how long do you think this will last until somebody passes out? Passes out.
Less than an hour.
Not going to be very long.
Let's find out.
But it's in the middle of the winter. We like that heat. No, trust me, you won't need that. You won't like that heat, because we'll just turn on the air conditioner.
No, that's not
How much heat can you extract out of it, using a regular air conditioner? Not much.
And plus the second thing is like, but if you already have running like 4,000 kilowatts, the air conditioner will take more energy. That's not reliable in your building.
If you need external generators to bring the power in, I don't think the air conditioner can extract all that heat out. Okay? And that's the problem with the data processing center. Because the density of computers is even higher over there. They have racks and racks and racks of computer. On one rack, they have 1U and 2U units, and each one is a high-end process. It is a high-end computer.
But that's why they have big air conditioners there, right? So they have big air
Oh, they have
conditioners.
huge
Air
heat
conditioners.
extraction mechanisms. Oh yeah, yeah. But still, the problem of packing more processing power is not the space. They have plenty of space. It has to do with heat extraction. Okay, so what do you think this has anything to do with the Cisc versus Risc discussion?
Get more RISC processors. And
Because
generate
now
less
we are
heat.
no longer looking at the absolute number, which is MIPS, okay? For the longest time, people were looking at MIPS as the measurement of performance, which is not, unreasonable, because this is million instructions per second. The higher this number, the more processing you can do. It's great until you run up to the thermal limit of a building like that, okay? So the new measurement is no longer just MIPS, it's MIPS per watt. In other words, per watt of heat generated, how much processing power am I getting out of it? That becomes the new standard or the new measurement. And interestingly, when you look at a bigger die like this, all the Intel i5, i7 processors, the MIPS per watt rating is usually lower than smaller processors, your Risc processors. So even though the Risc processors, one cannot nearly do as much as one of these, you can actually run many more of these to get the same number of processing power, but without wasting as much heat. Why is that the case? I mean, it doesn't seem to make sense. I mean, scaling should work in favor of the larger chip, not the smaller chip.
Because they need few cycles compared to what one is.
Well, the Risc processor needs more cycles compared to the CISC processor. But the CISC processor also has a lot of baggages. Okay? What kind of baggages are we talking about here? Okay, let me rephrase that question. Let's say I have, a MS-DOS installation on a hard drive, okay? Probably virtual. And I plug into a i7, desktop computer. Will it run? It will run. That's the baggage that I'm talking about. So what am I talking about here? Backward compatibility. Backward binary compatibility is a baggage. It uses silicon because it has to be able to recognize all the instructions, including the 8-bit instructions, all the way back in the beginning of DOS. And all of that silicon, in order to maintain the backward compatibility to the 8086, 8286, 8386, and so on, it's all taking transistors. So all those transistors are not translating into more processing power. It is simply translating into, oh yes, I can recognize that really archaic old instruction, even though we are now using 64-bit instructions. Okay? That is why Risc processors, which does not have the baggage of backward compatibility, is going to win out when it comes to MIPS per watt. They do not win out MIPS per unit or MIPS per chip, but they do win when it comes to MIPS per watt. All right? So are there any questions, any comments about this discussion here? Yep.
Well, in the case of newer processors, which is called, I guess, cisp processors in general, in order to get the performance that they advertise or that you want out of them for the consumer level, it requires more levels of cache memory for it to be able to share.
Yep.
Like with an i7, it has 3 levels of memory.
Yep.
Whereas with like a Risc processor, it's 1 level of memory.
Well, they can still have caches, with the Risc processors, but they are usually the programs are designed differently, so you don't even need to share the same memory space.
But it's not measured in megabytes.
Correct. That is correct. So let me go back and check on the virtual machine here. All right, and it's asking me where to install grub. We are going to install it to the root device, which is SDA. And we'll continue. It's finishing up. It won't be long by now. Okay. All right. So what type of devices run on Risc processors? Come on. You guys are in CIS.
Furbies.
Almost Furbies. Okay. Cell phones. Cell phones. Okay. Almost every single cell phone now run on an ARM processor, which is basically the de facto standard of commercial Risc processors.
Watches.
Watches, I think watches are slightly different. They have more of a ASIC, it's application specific, integrated circuit. All right. Our virtual machine is all done with the updating. Now here comes another part that you have to do. Yes, I could have included this image with everything done already, but I want you guys to do this, perform these operations too. How many people think, well, when I'm done with this class, I will never see Linux again? Well, I think if you decide to change major, maybe that will happen. All right, so the next thing we have to do is to install the packages that you need for this class. And the link is somewhere around here, right here. All right. So the packages that you need are binutils, GCC, GDB, make, Vim if you want to use VI, and libc6-dev. So how do we do this? How do we install all of this stuff here? I think I need my GUI in order to do it. No, you don't. You don't need your GUI. And let me go back to the page here so I can see that. All right. So I'm gonna put it side by side like this. So what you need to do is go to the virtual machine and say aptitude install, and then give it a long list. Okay. Binutils, GCC, GDB, make, Vim, libc6-dev. Oh, I forgot a 6. Okay, let me show you the command here. Oh, I did remember the C6. Okay, I just didn't say it, but I did type it. So just run the command. It will ask you, do you want to install 36.2 megabytes of archives, and after expansion 105 megabytes will be used. Say yes, and we'll be done. Well, that's only the first part. I can talk about the second part. How to get PuTTY to work. Later on too. All right. Well, I'm kind of surprised that nobody asked another question related to what we just talked about. Roshi.
Dash. And PuTTY to work from Windows or PuTTY to work from Arch?
Well, there's one problem that I have not resolved yet. Okay, there is a solution, but it's not the solution that I want. Okay, but I'll talk about it. So before we talk about that, I'm going to pass around the row sheet and also permission numbers. So if you're trying to add to this class, if you're adding to this class, whether you're on waitlist or not does not matter. if you're adding to this class, pick a number. Well, okay, pick the next available number, because I don't want people saying, I don't like this number, I don't like this number, I like that number, okay? Just pick the next one available. Pick the number and write your name next to it so that the next student knows that number is already used, okay? And then this is the row sheet. I'm going to pass these two around, and hopefully in 10 minutes, we'll be done. I think it'll be pushing it a little bit. Okay, I was kind of surprised that nobody asked the question that is natural coming out of the CISC versus Risc discussion. Well, if CISC architecture has an inferior MIPS per watt rating in general, then why are we still using CISC processors?
It's cheaper, maybe per dollar is cheaper.
Nope, it's not.
Faster.
It's because of Microsoft. To be more specific, it's because of
DOS.
It's because of Windows, but it's because of certain parts of the development process of Windows.
Oh, because the Windows kernel requires some backwards compatibility back to certain instruction sets that it's
Because they did not design the architecture well enough to be architecture independent. Okay, that's basically the reason. Okay, if you look at Linux, Linux can target how many different processor platforms?
almost all of them.
Yep. Almost everything that has a protected mode that has virtual memory implementation. You look at Windows. How many of those platforms can Windows target? There's the x86 platform, and then there's the ARM processor platform for Windows, the mobile version of Windows.
x86, ARM, and AMD 63.
Yeah, but the ARM architecture is close enough to the Intel architecture, so for the most part, we just consider that the same architecture. Yep.
Like on your website, on the packages needed, the command is, where is this at the bottom, run this command, it's because of the GCC.
The command that I listed is,
Yeah, it's,
oh, I didn't put GCC in here.
yeah.
I think GCC may be in there already. Okay, let me scroll up and find out. Yeah, GCC is not installed by default. It has to be brought in. But it might be one of the things that is already installed by dependency once you bring in the other packages. So go ahead and install GCC anyway. I mean, it's going to be
When you
useful.
install Vmware, it'll pull it.
Does it? Okay.
Sometimes.
Sometime. All right. So, okay, here comes the next question. We only have a few minutes left. How do you shut down a virtual machine? Okay, well, as I told the class on Tuesday, okay, people who follow me, I talked about that, on Tuesday. There are 3 ways to do it. One is an absolute no-no. One is not a good idea, and there's only one proper way to do it. Okay, so let's talk about the big no-no first. The big no-no is to pull the plug on the host computer. That is a super big no-no, because doing that will actually not hurt Windows in this case, because Windows has NTFS. NTFS is a journaling file system, which means pulling the plug is going to be okay. Okay, you might lose one file, and that's about it. Okay, but to the guest operating system, which is the virtual machine, it can be a lot more damaging, because the guest operating system is using a single file from the perspective of the host operating system as its entire disk, right? And because of caching in Windows, it is possible that some parts of the file is stored in RAM and not written to the drive just yet. So if you pull the plug on the computer itself, that content will be lost forever. And having a journaling file system is not going to help, because to the virtual machine, it is writing to an entire drive, but to the host operating system, it's just a single file. So never pull a plug or long push the power button on the host computer when you're running a virtual machine. If it can be helped, don't do that. Okay. Second one, okay, not recommended, but it's not nearly as bad as the first one, is to click this little X button here to close the virtual machine. It's actually going to be okay most of the time because it is equivalent to pulling the plug on the virtual machine itself. And with a journaling file system, it typically will not cause massive damages to the file system. But it's still not recommended. It's kind of like pulling a plug on a computer. So the best way to do it is to run the command as root. You run the command called power off. Okay. Yeah, but I cannot remember those options, right? So I just use power off.
What is the logout? It's actually the upper logout still on my case of the user out, right?
Say again?
Logout brings the user out, but still it logs off the user, right? The thing will stay on. The virtual machine will still stay on if it has logout in the root.
That is correct. If you log out, the machine is still on. It's just that at that time there are no active users in the system.
So basically, if I'm starting with a root and then ball, and then if I want to start with my own thing, you can go from my user log out from the root and start logging with my own thing, with my own profile.
You just log in as yourself.
From the root, you log in as yourself.
You can log out completely and log in as yourself.
So basically,
okay, guys, hold on. We are not done yet. Okay, I need to.
So log out first and then log out.
Yeah, you can log out as root first and then log in as yourself. Yeah. So now the first machine is all shut down. Then it's safe to turn off the host operating system. Okay, how do you back up your entire virtual machine? You have to copy the whole folder. There's only one file that is really big, like 1.6 gigabytes. There are better ways to do it because if you know what files are actually important to you, you can just back up those particular files. Now I have not really talked about how to do that yet. So I'll leave it to next time because we are not writing programs yet. There are something that's really nothing to back up at this point. But if you really just want to back up the entire virtual machine, just back up the whole folder and you're fine. Most people have terabyte hard drive these days, so 1.6 gigabytes is like it's not too bad. Yep, you can do it on your phone. Yes, it will just take a long time. Yes, but you can do it.
Yeah, I say just take it.
Yep. All right. So, are there any questions that I can answer? In about 2 minutes or so.
Let's just go to that. I'm dying to know how to do it.
Okay, we'll go to the lab in 2 minutes. Yep.
Where do you keep all your homework?
Sorry?
Where do you keep all the homework on your website? I was trying to look something.
Because I have hidden all the homework, so I'll only unhide and show them when it's time to do it. And I change the homework assignments every year too. And that's why you can watch the video from last year on the previous homework as help to do your homework for this year, but they're not going to be the same.
Okay, on your videos on YouTube, you have like some so you only don't give the dates for sure. How do I know like which year you did the homework, which homework? Do you have any like?
Oh, you mean from the past years?
Yes.
I don't have any next to that.
Oh, you have to.
You have to look for approximately the right time.
So basically, for like if you are doing the homework in like 2 weeks, so the last semester I look in 2 weeks and then I can.
About the same time. It can be off by a week or so.
Sure. And you say you do the homework in the first in the class, right?
Right. I will show the solution
in the 5 minutes of the video. I will be able to see it, right?
Yeah.
10 minutes of the video. I'll be able to see the homework or not.
Yeah, it depends on whether I get distracted by something else. All right. Question? We do not have any actual activity to do in the lab. If you want to set up your virtual machine, you're more than welcome to go to the lab and do it. Especially if you have an external hard drive with you, I would just do it, get it done, and not having to do it later. Any other questions? Yep, go ahead. Yes, you can also do it on your laptop computer. So what I'll do is I will wait for where's the row sheet? Who has the row sheet right now? Okay, so you cannot really leave until you sign up on the row sheet. Because if I get everybody into the class, I'm going to enforce the absences policy. Okay. Any other questions related to the homework and reading material and so on?
So you have a lab edition?
Say again?
We are coming to lab.
I am going to the lab today, but there are no planned activity in the lab. So the only thing I recommend you to do right now is if you have enough space on your USB thumb drive or your phone or something like that, I would just get this done. So that way you have your virtual machine ready to go. When we do have homework assignments to do, then you don't have to do all these steps. You can just get onto the homework assignment right away. So that would be my recommendation of stuff to do today.
You also have the
I have that on power.
That's good for me. That's good for me. I was on the hookup.
As a repository of files.
So you said they had 35 people.
Yeah.
They said
Yeah. That's basically how many sardines can eat. Like people eating Cyros, people like sitting on top of people like a Tetris. Oh yeah, it's like Tetris, like
There are some most virtual machines go out of the traffic is great, but inside traffic is so that's why you just sit outside so that the machine set files over there and the machine grab the files and go back.
So you can use
I'll explain that for you.
So you can use the Dropbox.
You can use Dropbox, but that requires the installation of the Dropbox app, or a web server. Okay, so the command line is simple installation, probably cannot use the Dropbox app.
So you do
Right, so that means you have to install I would talk about the solution. There are ways to do it, it's just they can both go to the FTP server. So one
no, I have a FTP server with virtual machine.
Okay. The problem is,
a modem. Router.
Well, the problem is incoming traffic to the Risc machine is usually blocked. So it depends on how you run the networking part of the machine. If you run it as bridge, yes, it will be okay. Not user mode. A virtual router. If you have a virtual router, a real router,
But will it work with the software?
as a FTP server.
I have a virtual machine. All of them are FTP server. I have a virtual. I have a router to go to. I have a local address. So virtual machine has a unique virtual address. So I can connect to the FTP server from.
As long as the FTP server is on the internet and not the intranet, then the virtual is it visible to the host?
Yeah, I got it. No, I'm actually slowly.
I use files.
Okay. So set up this everything. There are many, many ways to do it.
Yeah, I was just quick ask my plan is like VM Player, really clear on like that we should be putting this like actually doesn't hear let's see if there's evidence there. So maybe like delete any it would help, so it would just help. That's just I thought I'd recommend. Alright. I'll see you around.
All right. See you Tuesday.